Bode plot shows how a system responds to a signal at different frequencies. It has two portions to it, a magnitude and a phase plot. The magnitude plot shows how much the system amplitude amplifies or attenuates based on the input. That's captured on the vertical axis in decibels, while the phase plot shows how much the output is shifted left or right, so how much it lags or leads based on the input. Both of these follow a base log scale in the x-axis, so the horizontal axis for both of these is measuring frequency. So basically, together, the magnitude and the phase tell us what the size and the timing of the signal is changing based with frequency. If the input of sine omega t is sine omega t, the output ends up remaining a sinusoid at the same frequency. What ends up changing is the amplitude and the phase shift. So basically, the magnitude, which is the absolute value of GJW, ends up being greater than 1. The output amplitude will end up increasing, and if it is less than 1, the amplitude will decrease. So the thing that ends up happening with the phase angle is if it ends up being a negative value, it means that the system itself is lagging behind the input, and if it's a positive value, of course, it's leading. When it comes to calculating the magnitude in decibels, we take the magnitude of the system and we multiply by 20 log 10 times the absolute value or the magnitude of GJW. And then to convert back, we just do 10 to the power of the magnitude divided by 20. For my example, what I decided to use was a mass spring damper system, which is an input and the output being the force, and it's kind of going back and forth, up and down, or left and right. Basically, what we'll notice ends up happening is that at low frequencies, the mass will have enough time to follow the force, so it would be in phase relatively to the input force. But as we start to increase the frequency, the mass will have a difficult time keeping up until eventually it will most likely start to lag behind the input, as well as its amplitude will change a little bit. And then when we start to get to a very, very high frequency, the mass itself would be almost completely out of phase. Basically, at that point, it will either have a very difficult time moving, or if it is moving, it's completely out of whack with the input. Thank you for your time. That's it.